Okay, so we are discussing about pulley problems in the last 3 to 4 lectures. And now what we'll do is we'll discuss the pulley problem in more detail, some little bit of more complicated problems. So we studied about this pulley problem and we assumed that this pulley was rigidly fixed to a support. So when this pulley was rigidly fixed to a support, what were the equation? You had T minus m1 g was creating an acceleration in m1 that was going in upward direction. We have already discussed this in our last lecture, so I'm not going to tell anything about this. And this also we know that m2 g minus t equals m1 m2 a. Okay, now what we'll do is, instead of the pulley being fixed, now assume that this pulley is falling down with an acceleration a naught. The entire system, when I say it is falling, I mean the pulley and the masses, all of them are falling down with an acceleration a naught. So how to understand this? So imagine this pulley is now connected to a lift and this lift is falling down with an acceleration a naught. Okay, in this way also you can imagine. So now that the pulley along with the masses is falling down with an acceleration a naught, how to now draw or write the equation of motion? Now let me tell you, it's very easy. Okay, just 2 steps. Just remember that what happens when you fall down. So when you fall down, so when you are sitting on the ground, so what happens when you're sitting on ground? When you're sitting on ground, consider you have a mass m. So when you're sitting on ground, what is the weight acting? It's mg. When you're freely falling, what happens? You feel weightlessness. It means you had a weight mg. Now because the fact that you are falling down, your weight has decreased. How much it has decreased? It has decreased by same mg. And so what is your total weight now in free falling? It is 0. Similarly, if you are in a lift, so consider this is a lift and you are in a lift. Okay, so what is your weight? Normally your weight is mg, but if the lift is coming down with an acceleration a, then you will feel a little bit of weightlessness, not complete. Agreed? In the first case you will feel full weightlessness because you are freely falling, but in this case you will not feel full weightlessness but little bit of weightlessness. How much weightlessness? It is by minus ma. So the actual weight that you will feel inside the lift is mg minus ma, and ma is the reduction in your weight that you will feel when you are in a lift which is going down with an acceleration a. So here also this m2, the weight m2 will feel that its weight has decreased because of the free fall. Agreed? So when m2 feels that the weight has decreased, then obviously this equation will get modified. Now how to modify this equation? Take this side. Okay, just see what I'm doing. So I say that the m1, oh, we are talking about m2. Okay, so take this side, take this part this side. So why I'm doing this, I'll let you know. Okay, I've still not changed the equation. Now as I said that m2 is freely falling, no doubt it is falling with an acceleration a which is already there, but it is also falling with an acceleration a naught. So you see this m2, because of a naught, will feel a decrease in its weight, and because it is freely falling, so I need to decrease the weight of m2, and this decrease in the weight of m2 is due to the a naught. Okay, this decrease in the weight of m2 is due to a naught. Agreed? Now Similarly, what will happen to M1G? The M1G, I mean the M1 will also feel a little bit of weightlessness because it's falling down with an acceleration a naught. So there will be a modification in the weight of M1. So that will be by how much? By M1 a naught. Agreed? In this way you can easily solve. Now over in just 2 seconds I just framed the required equation without too much free body diagram, just using your intuition. We have framed. Now what you do, now just solve these two equations like you did earlier, and you can easily find all the variables that you need to solve. Agreed? Now what will happen if instead of falling down, consider the pulley will go up? So what will be the modification? So note down this one. I'm going to make some changes. Note it down. So what happens if the pulley goes up with an acceleration a naught upward? Remember, so have you experienced something when you are in a lift and when you are sitting in a lift, and if the lift is going down, you feel that your weight has decreased. And now when the lift goes up with an acceleration a, you'll feel that your weight has increased. So your original weight is mg, and because of the lift going up, you feel an extra weight on you, which is equals to ma. Similarly, if the lift is taken up with an acceleration a naught, then both m1 and m2 they will feel an extra weight. This extra weight can be said as the addition here. You see, when the moment I do the addition, it means what? I have added an extra weight to m1 by writing m1 a naught. And it is true, since the entire system is moving up, m1's weight has increased, and this increase has been reflected by adding some extra weight. Similarly, since the entire system is going up, it means m2 is also going up. There is an extra addition of weight that says that the weight of m2 has increased. So in this way you can easily guess the equation for solving the complicated pulley problems where say the pulley is going down or the pulley is going up. Okay, you don't have to do too much free body diagram. So if you do classical mechanics with full-fledged intuition, rest assured one thing, that you don't need too much laws to remember. Good use of intuition and you are done. So this type of intuitively doing classical mechanics will actually help you save your time. Okay, so we are done with pulley problems. Now go look at, find any book you have, and now that I'm sure you have understood everything about pulleys, now try to solve any complicated pulley problem, and I'm sure that you can be able to solve. Now in the next lecture we'll move to some other topics in classical mechanics.